This is Mr. Precella working with my business math class, discussing the future value of ordinary annuities and the future value of annuity dues. I've already defined what we mean by annuity. I've stated the formulas for calculating the future value of annuities. Now I want to do some homework problems. Problem number 1 says find the amount of the ordinary annuity based on the given information. R is $12,500. Well, that's the periodic payment. The interest rate is 6% compounded semi-annually for 6 years. The amount of the ordinary annuity. What's the amount of the ordinary annuity? Well, it's not too difficult to figure out which formula to use on this one. It's an ordinary annuity. You're told specifically. So we're trying to find the value of the annuity after 6 years. So I'm going to use the formula for the future value of an ordinary annuity. S equals R times 1 plus I to the n minus 1 all over I. Now we're told R, that's the periodic payment. That's $12,500. Now I is the interest rate per period. And we're told 6% compounded semi-annually. Well, that you calculate I, the interest rate per period, by saying, okay, 6% per year. Semi-annual means twice a year. So 6% semi-annual would be like 3% for first 6 months and 3% for the second 6 months. This lowercase I is the interest rate per period. N is the total number of periods. Well, semi-annual times 6 years. How many semi-annual periods are there in 6 years? To get lowercase I, we normally divide. To get lowercase n, we usually multiply. 2 times 6, so there'll be 12 semi-annual periods in here. So S equals R, can y'all see this, times, now I'm going to do some of this adding in my head. The 1 plus I, 1 plus 0.03, I can do that in my head and just say 1.03. If you want to put that in parentheses, 1 plus 0.03, you're just creating more work for yourself when you're punching it in. But I'll leave that up to you. So 1 plus I is 1.03 to the n power minus 1 all over I. To punch this into my calculator, I would, let's see, can I position this? I'm going to punch in the bracket number first. 1.03 raised to the 12 minus 1. Hey, what happened? Someone's turning out the lights in here. Minus 1. So there was nothing wrong with your computer or what you're watching. The lights went off. Divided by 0.03 and then multiply by 12,500. So at the end of 6 years, if they're making semi-annual payments of $12,500, $177,400 and how would we round that? 37 cents. But wait, did it say round to the nearest dollar? Yeah, round to the nearest dollar. So if you put in the 37 cents, my math lab's going to say wrong. So it's $177,400. Will be the value of that ordinary annuity after 6 years. Now let's try number 2. On problem 2, it says find the size of each of 7 payments made at the end of each year. So the end of the year, that's telling you it's an ordinary annuity, just like number 1. Into a 5% rate sinking fund. A sinking fund is an account that you put money in, saving it for a specific purpose, which produces $74,000 at the end of the 7 years. So, in problem 2, I think I'll draw a timeline. Let's get some color. This is a 7-year timeline. We want to know, okay, what's the value? Find the size of each of 7 payments. So, the periodic payment, R, is what we don't know. Again, this is end of the year, so it's going to be an ordinary annuity. Find the size of each of 7 payments. So R, we don't know. And we were just told the number of payments is 7. At the end of each year, into a 5% sinking fund. Well, if the interest rate is 5%, we're assuming this is compounded how? It doesn't say compounded monthly or compounded semi-annually. The interest rate always corresponds with the payments. The payments are being made annually, so the interest rate, we assume, is compounded annually. So I would be 0.05 over 1 annual period a year, so just 0.05. And then we're told that it's going to produce $74,000. That's the future value. That's S. So we're going to use the future value of an ordinary annuity formula, the same one we just used. S equals R times 1 plus I to the n minus 1 all over R. All over I. S is 74,000. R is what we don't know. Now the 1 plus I can do that in my head. 1 plus 0.05 is 1.05 to the 7th power minus 1 all over 0.05. So I'm going to calculate the bracket number, and instead of multiplying, once I know that bracket number, to solve for R, I'm going to have to divide. I'm going to be solving a linear equation, dividing. So let me get my calculator. I'm going to punch in the bracket number. Let me clear this. Let me lift this up a little. 1.05 raised to the 7th power minus 1. I'm calculating this bracket number. Now be sure to hit enter before you say divided by 0.05. So if we think of this as an algebra problem, 74,000 equals R times 8.142 ... Don't round that. To solve for R, do y'all agree you would have to divide by that 1.42 ... 8.142 ... So don't round anything yet. I'm going to punch it in like this. 74,000 divided by, and I'll hit second ANS to pull up that previous answer. So the amount of the payment is $9,088, and this says round to the nearest cent. So would y'all call that 67 cents? Okay. Oh, it's to make sure I'm answering, you see I'm answering these questions. $9,088.67, that goes there. And on the first one, what was it? $177,400, and that goes in there. Okay. So, any questions on problem number 2? That's how you calculate that payment. For any of these problems where you have to calculate that payment, you're going to wind up having to divide. The way I do this is I calculate the bracket number, and then I go whatever the S value is, 74,000 divided by that bracket number. Okay, I go second A and S. Do not round here, okay? Pull up that same number that's in the calculator. Now let's see. The ones I'm not doing right now in this video, 3, 4, 5, 8, and 9, there's separate videos for those. So I'm doing the ones that I haven't already made videos for, which is 1, 2, 6, and 7. So let's do problem number 6 now. A man deposits $15,000 at the beginning of each year. That phrase, beginning of each year, is something very important. It's telling us whether this is an ordinary annuity or an annuity due. Beginning of the period, that's an annuity due. So we're going to be looking at the future value of an annuity due on number 6. So a man deposits $15,000 at the beginning of each year for 18 years in an account that pays 5% compounded annually. So the payment that he's making every year is $15,000. So R is $15,000. And he does it at the beginning. That's how we know it's an annuity due for 18 years into an account paying 5% compounded annually. He then puts the total amount in another account paying 8%, compounded semi-annually for another 10 years. So there's 2 things going on here. This first part is an annuity. Then he takes all of that money, puts it into another account that pays 8% semi-annually. During the second part here, there's no annuity. There's no more discussion of making payments or anything. Find the total amount on deposit after the entire 28-year period. So the first part that we have here is a future value of an annuity due. Let's do that part first. Okay, this man is saving. I'm doing all this first part of the timeline in pink. R times 1 plus I to the n plus 1 minus 1 all over I. So R, the payment, is $15,000. Well, I've already written that there. I'll write it again. I is the interest rate per period. 5% compounded annually would just be 5% compounded annually. There's 1 annual period per year, so the interest rate per period is 5%. If it had said semi-annually on this pink part, you would have put over 2. Okay. N is the total number of payments or the total number of periods. Well, this is all annual, so how many annual periods are there in 18 years? Well, there's 1 annual period per year times 18 years, so N is 18. So punching, or plugging in. It's 15,000. How am I doing? Do I have room? Times 1 plus I, that's 1.05, to the n plus 1. You're going to, oops, you know what? I forgot to write minus r right there. Okay? That future value of an annuity due. 1.05 to the n plus 1 minus 1 all over 0.05, and then we subtract that artificial payment of 15,000. To punch this into your calculator, oh, there goes the lights again. They're trying to get us out of here, aren't they? Okay. I thought they'd fix that problem. 1.05 raised to the 19th power, oops, minus 1, enter, divided by 0.05, enter. Now that's the bracket number. So I'm going to take that number, the 30.53, and say times 15,000, subtract 15,000. So that's the amount of money in the account after the 0.0586, so would that be 6 cents? That's the amount of money in the account after the 18 years. This person's been saving $15,000 a year in an annuity due for 18 years, and he has that much money. Now it comes to the second part of the timeline. This man puts all that money into an account that pays 8% compounded semi-annually for another 10 years. He's no longer making any payments. Since he's not making payments, that's going to be a periodic compound amount formula. Okay, there's no more payments. A equals P times 1 plus I to the N. We're going to calculate that future amount there, A. The present value here on this part of the timeline, I know I don't have much room there. The present value on this part of the timeline is this future value amount on the pink timeline. So we're going to plug, for P, you put in $443,085.06. I, you divide 8% semi-annual, 0.08 over 2. There's 2 semi-annual periods per year. So that's like 4% for each 6-month period. Now, in the total number of compounding periods, you get that by multiplying. How many semi-annual periods are there in 10 years? 2 times 10 is 20. Now plugging in, A equals P times, and I'm going to do the 1 plus I thing in my head. 1 plus 0.04 is 1.04 to the n power 20. Clear. Let me see. I'm going to put in 44085.06. Ooh, times 1.04 raised to the 20th power. $970,853 and let's see, how many cents is this? I think they want us to round it dollars and cents. Would that be a 93 cents? I know the glare is bad. How much money does this man have after the 28 years? Well, $973,853.93. On this one, we use the future value of an annuity due, and then for the second part, the second 10 years, that 10-year period, we use the compound amount formula, periodic compound amount. We're running out of time, so I've got to do fast. Number 7, let's see. Ingrid wants to buy a car in Ingrid wants to buy a $16,000 car in 8 years. That $16,000 car would be a future amount. That's not present amount. In 8 years, she wants to buy a $16,000 car. How much money must she deposit at the end of each quarter? The fact that it says end, that tells you it's an ordinary annuity. So how much must she deposit at the end of each quarter in an account paying 5.5% compounded quarterly so that she will have enough money to buy that car? Well, this is a future value of an ordinary annuity. S equals R times 1 plus I to the n minus 1. Let's see. R is what we don't know. That's the amount of the payments. How much must she deposit? I is the interest rate per period, 0.055 divided by 4. 0.055 divided by 4, I'll just stuck that in my calculator. So 0.01375. N is the total number of periods. Well, it's 8 years quarterly. So there are 4 quarters in a year, 8 years. So altogether, there will be 32 quarterly periods. Now, we're going to punch this in. This is very much like the second problem I did today. Calculate the period, the payment given the future value. So 16,000 equals R times 1 plus I, that's a 1.01375 to the n, minus 1 all over I. So punch in the, that's what I calculated, 0.055 divided by 4. So let's see, I'm going to punch in that bracket number and then you divide. So this is very much like problem number 2. So here goes the bracket number. 1.01375 raised to the 32 power minus 1, enter, divided by 0.01375. So 39 this long decimal number here. And now we divide 16,000 divided by second A&S pulls up that decimal number. It doesn't round it, and you shouldn't round until the very end. Enter. 401. I think this one, if I recall correctly, it said to round to the dollars and cents. So we rounded as 401.42. $401.42 is the amount that she should be saving in that account every quarter so that she'll have the $16,000 in 8 years. Okay? So at this point, I just wanted to work 4 problems from the homework that I had already done. So for this assignment, there are other problems that worked in separate videos. Okay? So enjoy working on the future value of annuities, and we're discussing present value of annuities next. This is Mr. Precella, and thanks for listening.